So for question number 1, we have this crate that falls off the back of a truck. Right? When it falls off the back of the truck, it's moving at 20 meters per second. So we're told what our initial velocity is, and holy smoke. Okay, so we got an initial velocity of 20 meters per second. Okay, we know that the crate is going to slide along the road 35 meters before coming to a stop. Okay, what is the force of friction acting on the crate? Okay, what's the only force once it's on the ground that's important that's slowing the crate down? Friction. All right, if that's the only force, then it's also then by default the net force. Okay, it's the force of friction, but it's the only force that's bringing it to a stop. Gravity and normal force are already balanced because it's already on the ground. Okay, it isn't moving vertically once it's on the road. So the only force slowing it down is friction. So that's kind of the big leap that has to be made here. The sum of all forces is friction is the net force because there aren't any other forces contributing to it slowing down. Everybody follow me there? All right. So if I want to calculate the force of friction, I'm going to need to do m times a, but I don't have a. Okay, I know how heavy the box is. It's 50 kilograms, but I need to find the acceleration. Can I do that with these 3 pieces of information? I can use this formula here. Vf squared equals Vi squared plus 2AD, right? So what I'd be looking for in terms of givens here would be either this or this or both, okay? 1 mark for givens. Okay, 1 mark for realizing this is the acceleration formula that was going to have to be used. All right, solving for acceleration is going to look like this. Vf squared minus Vi squared over 2D. All right, so that'd be 0 squared minus, 20 squared divided by 2 times 35. All right, you can give them a mark for this step here. Okay, so we've got 20 squared divided by 70. All right, so the acceleration of the crate is going to be 5.714 whatever meters per second squared. Okay, obviously we want to keep all those decimals. I'm just not going to write them all. Okay, that's what we've got there. Our next step for our 4th mark is to do Newton's second law. So that's going to be 50 kilograms times the 5.71, which is negative. Okay, so you can give them a mark for that step. All right, so the force of friction acting on the crate to 2 significant figures, since that's all we have, is 2.9 times 10 to the 2 newtons. I'll accept negative or backwards as the vector there, okay? Because it isn't going forwards, and force is a vector quantity. Question? Oh, okay. All right, so that'll be our 5th and final mark there. Questions on number 1? Okay, when you first look at that question, does it seem like it should be more work than that? It does, right? It just seems like, oh, but all of it is intuitive, and that's the thing, guys. So much of the work is just stuff that happens in your head, not really stuff that you write down on paper in these kinds of problems. All right, looking at question number 2. Okay, a 3.5 kilogram rock is thrown vertically into the air. What kind of question is this? It's an elevator, right? Okay. Anytime something's moving into the air, it's an elevator question. So if I throw a rock, it's an elevator. Okay, so here's what I've got. I have a 3.5 kilogram rock that is being thrown upwards, okay, with some unknown applied force. It is being pulled downwards by the force of gravity, which I should draw as smaller, okay, because it is smaller. Give them a mark for their givens. That's their givens. Free body diagram. All right, my next step is that I need to find as many of these forces as possible, right? I know that the acceleration is 4.75 meters per second squared, so I can find F net right now. m times a. I have the mass, I have the acceleration. All right, so that'll be my next step. I'll take 3.5 kilograms times 4.75 meters per second squared and get my net force. All right, so my net force is 16.625 newtons up. All right, give him another mark for that. Okay, now I need to calculate the other forces because I'm looking for this force. And the other way to calculate net force is the sum of all forces. So that would be the applied force plus the force of gravity. They can have a mark for recognizing that sum of all forces was going to be important here. Okay, if they have it in there somewhere, okay, good enough. Okay, got to calculate the force of gravity. That I can calculate, 3.5 times 9.81. Okay, so we got 34.335 newtons working downwards. All right, so then I need to manipulate to solve for FA. So FA will be the net force minus the force of gravity, which will be 16.625 minus negative 34.335. Give them a mark if they got something like that for their fourth mark. All right, so we're looking at an applied force upwards, and I think we only have two significant figures here, of 51 newtons up. Okay, fifth and final mark on that one. But I did operations before that got me those numbers, right? It would normally, except that I had used other numbers to calculate the numbers I added. If there's more than one, you just go strictly by how many are there. Okay, mark out a 10 at the top, please. Let them see it, and then put them in a nice, neat pile right here, please.